Hello, my name is Carlos Rosemadan, and today we will talk about a solution of a transport process problem. Today, the problem we will talk about is about liquid benzene dropping in the ground, and we will need to calculate the, the concentration of benzene in 5 centimeters deep on the ground after passing 72 hours. For this problem, we will need to use some considerations. This consideration will be the next ones. The transitory system, one-dimensional transport, the system is stuck, no chemical reaction, the system infinity diffusion medium, and there's only benzene on the floor when the tank starts to leak. So for this part, I will do a small drawing that we can see in the presentation. That we can see here is the benzene, how it's going down in one dimensional only, that is the set, and it's going to the ground that is full of water, the ground. So for this, starting solving this problem, we will use the differential mass balance that we will have this with the law of Fick, and we will have this equation. In this equation, we can see we are talking about density, the diffusion time, and the reaction that is over here. For this problem, we'll change the density for the concentration, so it's more easy. So talking about concentration terms, we will have this one. So starting for this, we'll start developing this equation. So we'll have these three uh, dimensions. So for this part, we will eliminate the other two dimensions that like we say in the considerations, we only are talking about one dimension, so the dimension x and the y will be out, and we will only use the set like we can see in the presentation. Now that we have this equation, we can continue with the consideration we had before. So another consideration is no reaction. So we take out the reaction, how like it said, and we will have this equation. Now, another consideration is the system is stolen or is stuck, so there is no movement of physical of the liquid. So we can take out the velocity and we will have this final equation. Now, with this final equation, we will use to solve this. We will need to use some boundary conditions. These boundary conditions are so important to solve this equation so we can have the solution. Like we have see here, we have a small drawing how I will explain you how it is going on and how I choose the boundary conditions. The first one is the concentration is zero when the set is infinite. So we can say that Ca is benzene. So when set is infinite, we can see here there is no concentration. The concentration molecules are over here, and it's about this is too long that we say infinite. The second consideration is when the concentration of Satur, the concentration is equal to concentration of Satur when set is zero. The position is zero. We're talking about this part that you can see in the presentation. Now the third one is when the concentration is zero, the time is zero. But there's no time, there's no concentration. So with this three boundary condition, we will use a program named MATLAB, and we will introduce the equation and the boundary conditions, and we will have this mathematical model that we have over here. This mathematical models that is the solve of the equation before, we can see this equation general that we will use. The error phi concentration is equal to concentration of saturation times 1 minus error phi. For phi, we have this equation that we will use to solve it. So for this, we can see that in the problem before, we have some data. So these data are over here. We only change the time to seconds that we have over here. And the 5 centimeters, we change it to meters. So we can use the same units in every solution, that there's no problem. So like we can see, we solve with the equation of phi, and we have 1.552. So now that we have that, we will use a program named Excel, and will help us to have the error phi, and we will give us 0.971. And now for the last thing, we only substitute the error phi in the equation that we had before that we see, and the concentration of saturation, and we made the operations. Now that we have operation, we can say the concentration of benzene in 0.0 meters down the ground after passing 72 hours is 0.674. Thanks.